Okay, 3 dimensions. Plotting points in 3 dimensions, I'm not going to lie, it's not easy. Now, we know about plotting points in 2 dimensions, right? On a regular flat surface, right? We go x value left or right, y value up or down. So we've plotted them in 2 dimensions, but in 3 dimensions, it's just tough to illustrate 3 dimensions on a 2 dimensional surface, to be honest. How we try to do it, though, is we have 3 planes. We actually have 3 axes. We have an x-axis that moves kind of down and to the left, the y-axis, which is kind of down and to the right, and then a z-axis. This is like a height, all right? Up is positive, going this direction. Down would be negative, going below. But plotting points is a little bit difficult. The big things I want us to get down from this are x comes this way, y comes this way, z comes this way. We're going to plot a plane in just a second and explain how to determine if you have a plane given to you, a flat surface, is it x equals a number, y equals a number, or z equals a number. So as you take a look at these, if I ask you to plot, say, this ordered triple, I should say, 0, 3, 4. All right, 0, 3, 4, you go out 0 on the x-axis, so none out this direction. You'd start at the origin. You'd move 3 in the y direction, and then 4 up in the z direction. As you can see, you kind of illustrate it with arrows as you move whichever direction you're supposed to be moving. It is a little bit tricky, though, to actually draw that out. All right, if I were to draw it out on this, as you can see, it's illustrated over on the right, but I would start at the origin, come out 1, 2, 3 units in the y direction, and then up 1, 2, 3, 4 units in the z direction. So it'd be a point right there that I would label as P because that's the name of this one. Not going to ask you to try to draw these. It is very difficult to do a very good job on them. All right, however, when we're thinking about a plane, now a plane is simply in 3 dimensions what you can think of as a line in 2 dimensions. Right, in 2 dimensions, right, x-axis, y-axis, if I asked you to graph, say, the line y equals 3, you would go up to 3. We would fix that y value going across here, but our x's could go wild, right? They could be positive, they could be negative. You would get a line. Well, a plane is the same idea in 3 dimensions. So how we're going to be able to pick this out is if we're trying to say, okay, is it z equals 2? And we give you a graph. What you're going to notice is on the z-axis, we're going to come to a nice corner right at 2. The same can't be said for on the x and the y-axes. Well, what about if I give you the next plane? All right, looking at this one, you can see that down here, we come to a 3 right on the y-axis. So you can say that's going to be the plane y equals 3. Now, x's can go wild, right? Our x's can go out this direction in the positive way. They could go in the negative direction this way. The z's can go up forever, down forever. But the y has to be fixed right at 3. All right, the same thing can be said here. If you check this out, we have 4 right there in the nice corner, right at 4 on the x-axis. That's how I'm going to know x has to equal 4 for this plane. Y's can go crazy, go positive, go negative, doesn't matter. Z's can go positive, they can go negative. Same thing with y's. All right, to make this nice flat surface. So that's how you can kind of pick out if you're given a plane. Is it going to be x equals a number, y equals a number, or z equals a number? Hope this helps out.